Everyone, this is Infinity YouTube channel. Please remember to like, subscribe, and share. Okay, today we are going to work on something that is very important, a very important topic in chemistry, right? And that's called the oxidation and the reduction reaction. The oxidation and reduction reaction. All right, so oxidation and reduction happens in our day-to-day lives. Sometimes we may notice it, sometimes we might not notice it, right? But generally, every reaction that involves the products of energy or heat, so that type of reaction is always a redox reaction. And oxidation and reduction can also be shortened as redox reaction. Redox reaction. Redox reaction, which means reduction and oxidation. So one may ask, what type of reactions can oxidation and reduction be applied on? So oxidation and reduction can be applied by the chemist during electrolysis. Okay, when the chemist is working on electrolysis, what the reaction that actually occurs there is the redox reaction. Also, you may ask, how does reduction and oxidation affect my personal life in terms of what happens inside my body? So oxidation and reduction as well occurs during the metabolism of our food. Okay, so inside our body during the metabolism, what actually occurs there is the oxidation and reduction. Also, oxidation and reduction can also be applied in every area of engineering, like during the production of metals. Okay, metals are being reduced from their ores. Okay, now during that process of obtaining metals from their ores, what happens there is also the oxidation and reduction. As we know, there are several applications of it, which I've actually mentioned a few. So that will lead us to the definition of oxidation and reduction reaction. So what does oxidation and reduction reaction actually means? So oxidation and reduction is a type of reaction in which oxidation and reductions occur simultaneously. Alright, so in a reaction that involves redox, just know that both the oxidation and the reduction occur simultaneously. That means they occur hand in hand. Okay, oxidation cannot occur without reduction occurring. So both, as one is oxidizing, then another is reducing simultaneously. All right. So for us to further understand this oxidation and reduction reaction, we have to know the definition of oxidation and the definition of reduction according to some certain terms. Okay. So the first term we are going to consider in oxidation and reduction is, the first term is in terms of oxygen transfer. In terms of oxygen transfer. Alright, so the first one we are going to discuss on is in terms of oxygen transfer. So the definition of oxidation in terms of oxygen transfer is oxidation is the gain of oxygen. So oxygen is called O2, right? So oxidation is the gain of oxygen, and reduction is the loss of oxygen. Is the loss of oxygen. So this is the definition of oxidation in terms of oxygen transfer, and reduction in terms of oxygen transfer. So the word gain here can be used interchangeably with acceptance, okay? And the word loss can also be replaced with removal. So oxidation is the acceptance of oxygen by a substance, while reduction is the removal or loss of oxygen from a substance. So we are going to use an equation to represent the redox equation that is present in terms of the oxygen transfer. So a very good example of a reaction that displays oxidation in terms of oxygen transfer is the reaction between metal. Okay, let's use for instance iron 3 oxide. The reaction between iron 3 oxide is written first. So iron 3 oxide reacting with carbon monoxide to give iron and carbon 4 oxide. All right. So this is the reaction between this. And to balance this equation now, so we can add 3 here, and then we add 2 here, and we add 3 here. All right. So this is the balanced equation of iron 3 oxide in reaction with carbon monoxide to give iron and of course carbon 4 oxide. So looking at this reaction now, we can clearly see that iron initially had oxygen in it, but after reacting with carbon monoxide, so what we have left is only iron as a fragment. All right. Then on the other hand, carbon monoxide that was present here was oxidized to carbon 4 oxide, which means is that this reaction, what happens here, right, is reduction. What happens here is reduction, and what happens here between this and this is oxidation. What happens there is oxidation. Alright, so let's go back a little bit. I say oxidation is the gain of oxygen. So looking at this reaction now, we can see that carbon monoxide gain more oxygen, right? And reduction is a loss of oxygen. As you can see, iron 3 oxide lost oxygen to be reduced to iron. So this is the definition of redox reaction in terms of oxygen transfer. So before I go ahead to discuss the next step of redox reaction, so we have to understand 2 things. So the first thing we have to understand is what we call the oxidizing agent and what we call the reducing agent. Okay? So you can maybe jot it down as I explain what an oxidizing agent means and what a reducing agent means. So an oxidizing agent is actually an agent that oxidizes another compound, but itself gets reduced. While a reducing agent is an agent that reduces another substance, but itself gets oxidized. Right? So if you want to according to this reaction now, if you want to explain a reducing agent if you want to know what is a reducing agent in this reaction, that reducing agent is the agent that reduced, or is a compound. When I mean agent, I mean a compound that has reduced another compound or another substance, but itself got oxidized. Now looking at these 2 reactions now, as you can see, this compound, carbon monoxide, collected oxygen from iron 3 oxide. Since it has collected oxygen, it has reduced iron 3 oxide to just iron. Hence, carbon monoxide is a reducing agent. Because a reducing agent will have to reduce another thing to get oxidized. Then, in another way, iron 3 oxide is an oxidizing agent because it oxidized carbon monoxide, but itself got reduced. So that's the definition of an oxidizing agent and a reducing agent. Because as we go in further study of oxidation and reduction, we are going to be using these terms while explaining oxidation and reduction. Okay, so the second terms of this oxidation and reduction is in terms of oxygen transfer, hydrogen transfer. So the second part is in terms of hydrogen transfer. So hydrogen can also be called H2. H2 is also called hydrogen because hydrogen is an is a diatomic atom. Alright, so in terms of hydrogen transfer, the hydrogen transfer oxidation is just the opposite of the oxygen transfer. Okay, so in terms of hydrogen transfer now, oxidation is the loss of hydrogen, while reduction is the gain of hydrogen. Alright, so the difference between the oxygen and hydrogen is just they are kind of opposites in terms of the definition of reduction and oxidation. So oxidation is simply the loss. So when we lose or when a substance loses hydrogen, okay, that substance automatically has been oxidized. And when a substance gains hydrogen, that substance of course has been reduced. Alright? Now we are going to use a simple example. We are going to use a simple example to explain the reaction that occurs when hydrogen transfer is involved. And a favorite reaction that can be explained, that can be used to explain this step, is the reaction between hydrogen sulfide and hydrochloric acid. So when when hydrogen sulfide reacts with chlorine, so we are going to have HCl, hydrochloric acid, plus sulfur. So I'm trying to balance the equation now. We have 2 here. Alright? So this is an example of the hydrogen transfer, oxidation and reduction in terms of hydrogen transfer. Alright, so let's look at this equation that we have on the board. Now this is hydrogen sulfide. This is chlorine. And when 2 of them react, let's look at the products and let's compare it to the definition of oxidation and reduction. So we know that oxidation is the loss of hydrogen, right? So since oxidation is the loss of hydrogen, looking at this compound now, hydrogen sulfide, it means that sulfur has been oxidized because it has lost hydrogen in it. And chlorine, on the other hand, reduction is the gain of hydrogen, right? So chlorine, on the other hand, has gained hydrogen that was lost by the sulfur, hence reduced to hydrochloric acid. So this is a very typical example on how to understand oxidation and reduction in terms of the hydrogen transfer. Alright? So the third term we are going to look at now, the third term we are going to look at is oxidation in terms of increase in oxidation states. Okay? So in terms of oxidation number, so in terms of oxidation number, so mind you that oxidation number can also be called oxidation states. Okay? Oxidation number is the same as oxidation states. So I can interchangeably write oxidation number as oxidation states. Alright, so what may ask what is an oxidation number or what is an oxidation state? An oxidation number is simply that number that is being assigned to atoms of an element in a molecule. Okay, so when you assign the numbers that you assign to the atoms of an atom in a molecule, okay, so when you assign those numbers to it, and that number actually gives a net charge of the entire molecule, so that term is called the oxidation number. Okay, when the number that you assign to each of the atoms involved in an element of a molecule to give the net charge, okay, is called the oxidation number. So now, oxidation and reduction in terms of this oxidation number is, oxidation is increase in oxidation states. Oxidation is the increase in oxidation states. and reduction is decrease in oxidation states. Alright, so when there's an increase in oxidation states, so what we have, whenever there's an increase in that oxidation state, whatever we have there is oxidation, right? And when there's a reduction in oxidation states, what we have there is, when there's a decrease or a reduction, what we have there is reduction in terms of oxidation states. Okay? So, there are actually ways to determine this oxidation number. There are ways to assign, there are rules that are involved when you want to assign the oxidation number. You cannot just assign the numbers just like that. Okay, it follows some certain rules in order to assign the oxidation number. So I'm going to give you two of the best rules, or the most important rules, two of the most important rules in the assignment of the oxidation number. So that when you see a compound, when you see an element, or when you see a substance, you can actually determine its oxidation number, alright, and oxidation state. Because by determining the oxidation number or oxidation state, that is what will help you to know if there was an increase in oxidation number or if there was a decrease in oxidation number. Alright? So, the ways to determine this oxidation number is the first one to determine the oxidation number is oxidation number can be determined by the algebraic sum of each of the charge that is present in an atom of an element. Okay? When you add that charge, and that charge that you added is equal to the overall charge that is present in that compound. So that compound can be determined through that way. The oxidation number can be determined through that way. Alright, so let me just break it down with a simple equation. So when you have a compound like sodium chloride, right? The overall oxidation number, the overall charge of this reaction is equal to 0. How do I know it's equal to 0? Remember I told you that oxidation number can be determined by the algebraic sum of the individual charges, right? The overall sum of the individual charges will give you the oxidation number. Now, sodium is a metal, is an alkali metal, and this metal can give out one electron. So when it gives out one electron, it becomes positively charged. So since it gives out one electron, it is plus 1, right? Because it's giving out one electron. Alright, then chlorine, on the other hand, is an electronegative element which accepts one electron to fill up the outer shell. So when chlorine accepts that one electron to fill up the outer shell, it has a minus 1 on its charge. So positive 1 minus 1 gives us 0. So that is how I know that the addition of the charge is actually going to give me 0. So but a simple term to use is that when we are trying to calculate for the oxidation number or oxidation state of a compound, what you should do is that if that compound does not have a general charge on it, like a ligand or other compounds, just equate that number, just equate that compound to 0. Okay? Now let me give you a second example. Let's say you have a compound like this. Right? Let's say you have a compound like this. Okay? Manganese 4 oxide. Let's say you have a compound like this. Good. So what you do here is that this particular type of charge will be equated to the overall charge that is present. And the overall charge that is present in this compound is a minus sign. Right? Minus 1. That means the algebraic sum of this is equal to minus 1. Alright? So these are ways to determine the oxidation number of a compound. So, but in the later video that we are going to do, so we are going to solve some certain examples. We are going to solve some certain substances and see how we can easily calculate the oxidation number. All right. Now, this is how to do it. Now, the This is for the first one. Now for the second aspect of the rules now, that I told you, remember I told you that we're going to look at two rules where you can easily, assign the oxidation number to a compound or to an atom of an element. So the second part of it now is that any compound on its own, be it a monatomic compound element, be it a monatomic, any element at all, be it monatomic, diatomic, or whichever way, but as far as it's standing on its own without reacting with any compound, that that atom of an element must be equal to 0. Let's say, for example, hydrogen just on its own, sulfur just on its own, potassium just on its own, all these are equal to 0. That is their oxidation number is equal to 0 because they are not reacting with anything, so it is in its neutral state. Remember, for a reaction to occur, for this to occur, like this kind of reaction, for this to occur, they have to interchange their charges, okay? So before a reaction occurs, there must be charges that will be present. But if an atom of an element is just on its free state, there is no charge that is occurring, and that element is on its neutral point. So since it's on its neutral point, then it is equal to 0. So we are going to see a few examples I told you in our later video when we are going. Now the last one is in this definition of oxidation and reduction is, the last definition is in terms of electron transfer. In terms of electron transfer. So I would say that reduction and oxidation in terms of electron transfer is literally the most important among all these definitions. Alright? Because I feel that this electron transfer occurs in every other reaction. Okay? So since it occurs in every other reaction, that is why I term this as literally the most important definition of oxidation and reduction. Alright, so what is oxidation in terms of electron transfer and what is reduction in terms of electron transfer? So let me write it on the board. So oxidation in terms of electron transfer, oxidation is the loss of electron, and reduction is the gain of electron. Alright, so this is a very simple definition of electron transfer, oxidation and reduction in terms of electron transfer. So when an atom of an element loses its electron, okay, when it loses its electron, it is called oxidation. And when an atom of a compound or an element accepts the electron that was given out by some other compounds or elements, that is called reduction. Alright? So we are going to look at a few examples and see how oxidation and reduction occurred in that reaction. So let's look at the reaction between copper 2 oxide and magnesium. Let's look at this reaction. So what we have is copper plus magnesium oxide. Alright? So this is a simple reaction that oxidation and reduction can be used to explain in terms of electron transfer. But I want to give you a little code. I want to give you a little insight. In a particular reaction, you can use any of these terms to explain oxidation and reduction. Because before I continue on this definition of the fourth one, you can use this same reaction to explain oxidation and reduction in terms of oxygen. Okay, because oxygen is involved. You can also use this reaction that I wrote on the board to explain oxidation and reduction in terms of oxidation number. Okay, then you can also use it to explain the terms of electron transfer. It is not a particular equation, like it is not just one particular equation that is peculiar to a particular oxidation and reduction, right? You can use different definitions of oxidation and reduction to explain a particular reaction. Okay, I hope you understand. Now let's try to put oxidation and reduction in terms of electron transfer to explain this reaction. But before we explain that, since we are talking about electron can be an electron in chemistry can be substituted as E raised to the power of minus, like E minus, right? So whenever I write E minus, just know that I'm talking about electron. Alright? So let's continue. So since I am dealing with electron transfer, I have to write this equation in its ionic form. Okay? How you give out the electron. So looking at this reaction here, this should be copper 2 ion reacting with magnesium to give us copper reacting with magnesium 2 ion. Alright? So this is what we have. Now let's look at this reaction. Let us look at this reaction and see what we have here. So as you can see, I said oxidation is the loss of electron. Okay? So whenever a compound loses an electron, that compound is oxidation. And that reaction is called oxidation reaction. And whenever a compound gains an electron, that means reduction has occurred in that reaction. So which means that magnesium reduced copper 2 ion by giving them electrons, okay, to neutralize the charge. Hence, magnesium is a reducing agent. Alright? And copper 2 ion, on the other hand, is an oxidizing agent. Alright? So, because it oxidizes magnesium in this reaction. Okay? So, looking at this reaction that we have here, if you want to explain this particular reaction in terms of oxidation number, for instance, if you want this oxidation number to explain this reaction, you can see that oxidation is increase in oxidation state and reduction is decrease in oxidation state, right? So the oxidation state of copper here is 2. But looking at this reaction, the oxidation state of copper here is 0, because I told you any atom of an element on its own without reacting is 0. So the oxidation state of magnesium here is 0, but the oxidation state of magnesium here is 2, which means that magnesium oxidized and copper reduced. Are you seeing it? So this is a practical example of what happened if you want to define it in terms of oxidation number. And if you want to define it in terms of electron transfer, of course magnesium here reduced copper 2 ion by giving them electrons. So it gave copper 2 ion 2 electrons so that copper 2 ion can be reduced. Alright? And for that reason, magnesium is a reducing agent, while copper 2 ion is an oxidizing agent. Remember what I told you? I told you that a reducing agent is an agent that reduces another substance and itself gets oxidized, while an oxidizing agent is an agent that reduces another compound or another substance, but itself gets oxidized. That is for, an oxidizing agent oxidizes another, but itself gets reduced. Alright? So these are the definitions of oxidation in terms of different varieties. So one may decide to add oxidation in terms of electronegative elements, one may try to add oxidation and reduction in terms of electropositive elements. But whichever one we are going to add lies on these four definitions. Okay? So at the long run as well, we are going to solve, and we are going to see how we can determine the oxidation number and how we can determine or the oxidation state in a compound. Okay? So I hope this video was useful and helpful. Please remember to like, subscribe and share. Okay? Remember, this is your favorite channel, Infinity 2 channel. Thank you.